Hi and welcome to Geeks for Geeks. Today we would be discussing the problem longest substring with distinct characters. So as the name suggests, we need to find a contiguous segment of the array, that is EKSORG, and all of them contains distinct characters. So now that is why we can see that here EKSORG contains only distinct characters and only one alphabet can be considered because all alphabets are same. And then we have ABCD. So ABCDF is the longest character which contains distinct characters. Fair enough? We can see that. So now that we have understood it, what can be the approach? So longest substring, the brute force approach I can think of is consider all substring and the longest substring which would have distinct characters would be my answer. But wait, that's not it. See, I would give you a scenario. Let's say I have G. So I have G at this point is equals to 1. The count of G is 1. And then the count of E is also equals to 1. Then when we hit the next E, we see that the count becomes more than 1. So at this point, considering G and E with any other, we can't really ignore this E na. So if we consider this, 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 if we consider any substring starting from this point, then this would be useless. So what we can do is, we can stand at each index and we can see till what point I can go. So if I stand at G, I would be able to get GE. If I stand at next T, I would be able to go till this point only. If I stand at this point, I would be able to go E, K, S, F, O, R, G. So I found the result. Let's see more. Can I have more better length? Then I would stand at the next K, then S I got, then F I got, then O I got, then R I got. And then I got G, and then E, and E again I got. So this point I can't really consider. So how many characters did we got? 1, 2, 3, 4, 5, 6, and 7. So let's start from this index. So if I go at E, K, S, F, O, R, G, and then again we would get E. So we need to stop at this instance. So we got that we need to go till this point. So let us start from K itself. Okay, let's do one more iteration even though we know that we have found the result. Let's start K is equals to 1. Then we have S is equals to 1. Then we have F is equals to 1. Then we have O equals to 1. Then R we would again have equals to 1 because R is not present. Then we have again G. G is still not done, so G1. And then E. Do we have E? No, we don't have E. When again we have E. This is the point we can't move forward. So we went till this point to this point. So how much is the length? Again 7. So the longest length would remain 7, but we have this also, we have this also. We understand that. So Siddharth, we are standing at each index and going till the farthest point. So let's think of a better solution than this. So let's see. If I stand at this index, how far I can go? I can go A is equals to 1, then B is equals to 1, and C is equals to 1 at this point. So when I reach here, I'm just exhausted. After that, if I add this one, this would be disrupted. So I need to remove what? I need to remove the, so if I come here, the count becomes 2. I need to find the distinct occurrence. If I come here, the count becomes 2. That means the previous count needs to be subtracted. The previous count which was contributing to this, that needs to be subtracted. Then only we can move forward. Make sense? Make sense? We are using a sliding window approach here. So the previous count would become 1 when? So let's say I incremented this count. So I start from here. The previous count became 1. And this is what we wanted. So now, earlier, the value that we got was ABC. This time we got BCA. And yes, we are getting the potential results every time. So now this pointer is this side. So I can say A is now processed. The contribution of A is not really here. Then we moved to this point. Then when we moved to this point and we added that contribution, it became 2. So we need to remove the last time when b became 1. So I just came here, subtracted it, it became 1. Do I get the potential value again? Yes. CAB is again a potential 1. CAB is again a potential 1. Now, after we have processed this pointer, move forward this. Again, C becomes 2. So we need to remove the last occurrence of C. So if I just move forward and remove, after removing, if we move forward, it would again become 1. And we again got a potential candidate, that is ABC. Then we again moved to 1. This is the interesting point that needs to be highlighted. We again moved to 1. B became 2. So now this point, even after removing A's frequency, it becomes 0. But still we have not removed the previous occurrence of B. Now I need to remove this also, then move forward to this. And now this would become 1. And now we are satisfied. So we again got a potential candidate, that is C and B. So now, just now you observed, you need to remove till you reach this character. So we would have a left and a right pointer initially. First we would expand on the right pointer as far as we can. Then when we see problem, we just start shrinking the L until and unless the problem is resolved. In simpler terms, we start from L and R. We keep incrementing the R. When we reach a problem that yes, this is now a problem. So now we start shrinking the L until and unless this problem is resolved. So now this is a sliding window approach where L is equals to 0, R is equals to 0. R would first move forward, then L would move forward. Makes sense? Now, the space complexity is constant because we would be storing only 26 characters here. And the left and the right pointer, it is big of n. Because of what? Because each index would be processed twice. One L would increment, then A would decrement. L would first increment its value, then from back R would increment its value, and then L would decrement its value. It's like one person would first add that contribution and then the next person would remove that contribution. So each element needs to be accessed twice. The number of operation is 2 multiplied by n. The big O space time complexity is big O, but we are doing 2 iteration of each element. Let's say you give this approach to your interviewer and interviewer asks you to optimize more on this. So what can be a better optimization than this? So now if you observe, what is the point that I need to remove? The point that needs to be removed up till this point is the last place where this problem was created. We are concerned about removing this till this point. We are concerned about removing till this point. So why to come, and we just need the length also. So every time if we keep the index of it, think. Every time if we keep the index of it. So now let us start again. So this is left and this is right. This time instead of the element, we would just store the last position where it was located. 1, 2, 3, 4, 5, 6 and 7. Just store the index. So first we would have A of R. So we would store A is at A of 0. Then we would move forward the R pointer. We would say B exists at 1. Then we would move the R pointer. Then we would say C exists at index 2. Then we would move this pointer and we saw that this exists at 3. So now there is one thing what we can do is we can increment the L and start from A and remove this. One way can be done by this. Other way can be done is that we would just consider, first we would have the result. Answer is equals to L minus R, that is 3 minus 0, that is 3. And yes, we got that. But now I don't want to make L move forward one by one. I would just go to the index that is causing a problem. The index that is causing a problem is B. So I need to remove the last occurrence of B. Last occurrence of B was what? 1. So I would directly make L is equals to 1. It's not like we moved forward. We just shifted what B's value was stored. Now we would store here, and we would update b is equals to b's index plus max of this index, which would automatically update to 3. Okay, we now know that this would be the one would be causing a problem. So we would be now sitting here. So basically, we don't need to travel all the way from that and keep decrementing and then moving forward. We can just store the last index, and that would tell me where to jump off, because only one element is causing that issue, and to we need to go till that point. We need like the L needs to come till that point where that was last located. This is the issue, no? So we can just store the index in the map itself. We don't need any we don't need a vector. Why? Because only one index would be stored. So that would store the last index. It would tell me till what point I need to go, and it would directly point me to that. By doing this, L is not walking over again. Only R is walking. So that is only doing an operation, and the space complexity remains the same. Now let us see the solution. So we would get the maximum length of n. Then we would initialize the rest to r. Then we would initialize that everywhere for all the characters. We don't have not seen it. -1 basically. Then this is start. Start would start at 0. End would start from 0 till the value of n. Then what we would do is we would first update the last index of that +1. We would first update. So even if the last index was 3 or 4 or whatever be the scenario, we would update that index first. Then we would see end minus start +1. And earlier, let's say the value updated was 1. So we calculated it, and then we just updated it to 3. Then we updated it to 4. Because that it would hold only one element. So this keeps incrementing, and this would be accordingly updated. End minus left minus r+1 is just to compute the length between 2 points. Okay, and then the last index, whatever is the last index or whatever was previously kept, okay, whatever be the scenario, that would be given to the start. If the start is less, it would remain the same. If the current is more, the start would become this. Okay, so it's like if let's say the scenario is something like this. If let's say A, B, C, D, and the current is here and the start is here. Okay, last index was C. So that is whatever is the maximum, it would directly jump over here. This is maximum, it would jump over here. If this and this both are pointing at the same position, it would remain here. Okay, whatever is the maximum would be assigned to that. Now let us see if the solution works or not. Let's just compile, run, and see. And yes, we are getting a correct output for the sample test cases. And yes, we got an AC. So that was it from my side. Thank you and have a nice day.